Welcome everyone to this session of Fundamentals of AWS Elementals. The core philosophy of this is to get us kind of familiarized with how the elemental services actually work and what it is and why we need it. Because I'm pretty sure, I think specifically on the M2A side of things, we use it every day, but maybe you know, but when I started, I had no idea what it was. I just understood I'd push a button and something happens and magic comes out. But obviously, as time goes on, I've had the opportunity to meet people from the team, to work with it a bit more. And I thought, like for my team, now that I manage it, I always like to do this session so everyone kind of understands what it is and is not blindfolded by anything. So yeah, fundamentals of AWS Elementals. Those of you that watch Office, you obviously have picked up on the little pun there. If not, I highly recommend you watch it. A very smart man once said, streaming videos over the internet is very simple. And this was my reaction when they said it. It's not simple. It cannot be simple, right? On a day-to-day setup, like for those of you that are not like super technical, a regular website or API or whatever you want to use. So CloudFront gives you 5 terabits of data transfer per second. And 99.99% of the time, that team, that company will never reach that bandwidth. Like 5 terabits is like a lot of data for a regular team. For a video team, it's probably like 3 seconds, 4 seconds worth of data. We will eat through it, no questions asked. Last year for the World Cup, I was in a team and we were trying to, get the UK streaming working for video. And we discovered that like on an average, at least in the UK, for a 1080p stream, 25 FPS frames per second, we needed more than 11 terabits at the same time. So you can understand why it's not a simple thing. And there's another question as to why it's not simple is because it's a continuous frame. There's no real oh, I've done it once, I can do it again kind of mentality. Caching is great, but caching is not the typical caching that you might experience with any other systems that video needs to deal with specifically. So streaming video is actually not simple. If you think that, if you say that, oh, I just open YouTube and things work, no, it's all I call it hokery pokery in the back end to make it work. We need to be thankful for this because just on streaming alone have driven the caching technology forward, the computing technology forward, because of the fact that streaming is not easy. Let's have a look at how a typical video streaming pipeline would look like. You have this bit. So this is basically your studio where people are talking or creating content. If it's football, this is the stadium system. This is the stadium cameras that are coming in. And then you need something to encode the video, obviously. So this encoding is basically translating the video to something that device can understand. Because again, when cameras are just sending bits, and sure, everything is bits, but that doesn't necessarily mean every device actually understands the same bit format. So this encoding will create a generic video format. We'll get into the details later, but for now, it's important that we understand why we have these steps. So encoder encodes the video into a format that everyone kind of sort of accepts, understands. Then you've got packager. And the packager is the one that's responsible for adjusting to device types. So Apunmai likes his Windows phone for some reason, and Shoaib here likes his Android device, and I like my Pixel Watch or whatever, I don't care. We all have different needs, and the packager is the one that's going to package the content for you. So think of it when you buy a MacBook, for example, if you buy it through a company, you get a different box than the one that you'd get for a consumer, or even AWS account. Your typical AWS account versus your organizational AWS account actually look different. So that's packaged differently. That's what this packager is doing, right? Once it's being packaged, you need a storage. So this is the simplest one, Nowadays, storage is cheap, so we don't really talk about this. And then you've got delivery. This is the bit where the user interacts with it. where, I don't know if you guys remember, a few minutes ago I was talking about caching. This is where like all the caching would happen, because if again, video is real time, right? Which means if something's happened, it's not like it's going to change again. It has happened. That 6-second clip, the striker scoring that goal, that has happened. And there will be someone in this 5 million users who will reach that clip first. And once they do, you don't want it to be regenerated again for whatever device type. So this is where, like, you want to cache it really heavily and store the video somewhere. We call it the last mile delivery, or like the edge location delivery, so things like CloudFront, Fastly, Akamai is a big one. This is what they're doing. So we'll start kind of creating some basic FFmpeg commands first. So this one, I actually have it ready. I can do it, no problem. You guys can see my terminal, right?
Yeah.
Okay. So what I'll do is I'll create a basic FFmpeg video. Another useful thing to learn if you constantly use with FFmpeg. So I'll even run you guys through the command. So I talked about how like there are these things called filters. So this lev-fi is an internal filter that FFmpeg has, which lets you create test source. I think this is pretty self-explanatory. You've got test source, I'm telling it the size, I'm telling it the frames per second rate. And then I've got another one. So like I said, you can have multiple inputs, so multiple layers, multiple filters. And this one is the audio filter. So sine frequency, 1000, sample rate, blah, blah, blah. And this is a very important flag. This is RE, which means read at native. So this will actually prevent the video from just continuously counting up, and it will synchronize the counting up action with whatever the native speed is, which is 25 frames per second, right? And I've got another filter, like I talked about. I don't know. Yeah, I've got another filter. So this is a video filter, as you can see, filter : V. So that's video. And then this is the filter. Again, these are all like internal FFmpeg tools or built-in modules, if you want to say. So draw text is one. And then I'm saying, can you draw a text? And the text is craftsman. And then colon, I've got like the width and height. Oh, sorry, X and Y, which is, the positioning. And like I'm doing some basic math to basically center it. Because I have OCD, I need it to be centered. So I'm centering it. And then I've got font color, I've got font size, and this is the out. This is where like a bit of the magic happens. So I'm saying, hey, can you use this this MPEG TS, which is a format, by the way, and -f is a force format or like receive format. So I'm saying like, can you when you create this video and output it, can you please format it for MPEG TS? MPEG is moving pictures. What was it? Moving pictures experts group, and then TS is transport stream. I'll come back to transport stream later. Just gonna get rid of SRT for now. We'll talk about SRT later. I'll just do a UDP for now. UDP, I want to do it on a local. So 127.0.0.1. So this will, as you can see, this is starting to generate the video. And have a look at the speed. You'll see like the speed gradually get to 1x or close to 1x. This is the -RE flag that I talked about. That's what's preventing it from like going out of control. Then I'll create another tab. So remember, what did we do? We've created a dummy video. We've applied some magic filters to it, to make it look nice. And then we're outputting it to our network. So UDP, that's our network. And this is my local address. So in here, I'll do a bit of magic. If I can remember, ffplay UDP : 127.0.0.1 : 5000, I want to say. So it's trying to connect. Hang on. Oh, there you go. Sorry, it's a bit loud. Can you see that? So that's the video that I've created. I know it's a bit loud. I'll turn it off. But did we all see that? How like,
Yeah.
FFmpeg actually created a video and the video was counting up. Right. So that's a very common tool that a video engineer would use to like generate dummy videos. Like if you go to USP, unified streaming packager or unified streaming, anything to do that, they will also kind of use the same example because it's predictable. If you're writing like video tests to do like OCR recognition, it's a very useful tool. So it's good to have handy. But so on step one, I'm basically emulating how a studio would send stream. So this is your cameras. This is your studio stuff. This is the cameraman that's recording the football match or whatever you want to call it. So for us, I guess, for us, we're just going to use this dummy source, and we are basically transferring it from one place to another. So this is, if you consider this command to be my source, this command would be my destination. And you can immediately see that there's a problem that's being created. Can anyone shed some light as to what the problem might be here? Like, it lets you do all of this magic that we talked about and solves all of these problems in the cloud. I'll first do a quick demo of it. So I've got a AWS Media Connect setup. This is the public outbound IP. I really like SRT format SRT protocol because it's just simple for me. I can write it pretty quickly, and it's simple. It offers all the features that you might want. A lot of companies really like it. SRT. That's a good one. So I'll change the protocol. That's my favorite protocol. Yes, upon that, correct. That is because it's simple. It gets the job done. It works. It looks nice and it's fast. Like RIST or Zixi, which I'm not a big fan of. I'll start this. So it's going. We'll wait a couple seconds for us to see like how we've connected. It's going to take at least a minute for data to generate. But in that 1 minute, can I ask like if we all understand what Media Connect actually does? Media Connect is basically a transport mechanism. You give it's like a jumping point. It's like a router, even you can say, for media. So you give it something. So I'm giving it an SRT listener. Yeah, upon where you need to leave. And
all right.
and you can have output. So for example, আমি শোয়েব ভাইয়ের কাছে ভিডিও পাঠাচ্ছি। এখন শোয়েব ভাই হচ্ছে আমার ব্রোকার, middleman, right? And like আকাশ ভৌমিক ভাই শোয়েব ভাইয়ের কাছে টাকা পয়সা দেয়, তার রাইটস ম্যানেজমেন্টের জন্য। That's fine, no problem. আমি শোয়েব ভাইকে কি ভিডিও পাঠাচ্ছি সেটা আকাশ ভাইয়ের concern না. We don't need to talk to each other. I can just send it to Shoaib bhai, and then Shoaib bhai can create outputs for Akash bhai and like Akash bhai bandhu bandhav, and all the people that are subscribed to this, right? And there's a lot of options that you can put. I'm not going to go into that one, but protocols. So these are all the protocols that we have available. And so Akash bhai jeta accept kore ei lister moddhe theke seta diye ami deliver korte pari. And this actually includes like, I would say 60 to 70%. There's like RTMP that this doesn't understand, but RTMP is dying anyway, so you don't have to worry about that. So yeah, so that it makes it super easy to deliver video across the globe, and it takes care of networking. It takes care of encryption and protection. When I was sending this video, I could have had it encrypted. See, there's an encryption decryption flag. I can do a protection on the CIDR block. I can put it in a VPC as well. So there's a lot of things, and obviously the monitoring, the alarming, and all the other AWS jazz comes with it. So that's one of the services that AWS gives you, Media Connect, to securely, reliably transport video. Right. So baseline level, blah 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 blah. English of I think we understand. Like there's nothing that's like cryptic about this, right? Thumbs up. I can proceed, or we can actually dig a bit deep into what it's trying to do. Okay, thumbs up. Okay, so I'm generating someone called it a manifest. So I'm generating a manifest. I'll open another terminal, and if I do an alert, I should see. Yep, you can see that I've got these things that are being created. We talked about how index.m38 is the manifest. What would happen if I do an FF play on the manifest? Any ideas?
Start playing.
It will start playing. And the browser will also start playing now. Okay, that's good. We can see that. Thumbs up. I'll turn it off because it's really loud. Okay, cool. Let's play on index. I'll go with 10, I don't care. What do we think will happen?
Play the segment.
Yeah,
Yeah,
exactly. Play the segment. Play the segment. So it's not going to continue playing. It will die as soon as like the segment runs out, which is 10 seconds.
How long is it? It's 10 seconds?
I think default 10 seconds. Yep. There you go. It stopped. 10 seconds.
Stuck.
Which means adaptive bitrate streaming is actually nothing special. It's just chunking the video up into usable chunks. And you might be wondering, well, why does it do that? Well, because like HTTP was not designed to kind of have a consistent, persistent connection. So on HTTP, you can just request something, you get something back, request something, you get something back. So the user does not understand what's happening, but the video just plays, and we have no problem with that. Which is why we like to chunk things up. Plus, also, it gives us more benefits, some of which I will not go into, like you can do dynamic content insertion, ad replacement, content replacement. You can do DRM because of that. You know, there's a lot of possibilities that this single change gives us. There's also a drawback, and that is delay, because we can only chunk video if the video has happened, right? So the player needs to run before we can show you the player is running. That means there's always going to be a certain amount of delay before we can do something. Whereas if it was a persistent connection, there would still be delay, but those delays would only be network delay. Like, you know, the amount of time that the data needs for it to like reach to you, that would be the only delay. But with ABR, this is a drawback that we deal with. And there's also, we have been trying to fix this, like low latency HLS is something that DAZN's been really pushing lately. I've seen a lot of other companies have been doing as well. HLS has official support. MPEG, I think, is on beta yet, but you know, that's coming. So that's what adaptive bitrate tries to solve. It tries to give us a stability over quality, and chunks the video, and which obviously makes us, you know, be able to use the video as just a simple video clip instead of like a 13-hour long stream that probably no browser can download or deal with, and you'd run out of memory if you tried to play back videos like that. There's a lot of other services that AWS offers that are under the Elemental banner. So we've talked about Media Connect, Media Convert. We did not talk about Media Package. As Apunbhai said, packaging is a very complicated topic. But generically speaking, packaging, like I said, it will basically try to adapt to whatever device that's asking for the video. So if I go back to my original slide of this, how I'm saying like, oh, I'm an Apple device. So just like that, what happens if it's an Android device? That's the kind of thing that packaging would generally deal with. Yes, sure, but I will do one on
Why one? If there are people interested.
I'll do one on Media Tailor, you know, for ad insertion. Have you guys used Media Package V2? Any raise of hands, show of hands? Okay, Akash, of course.
Not yet.
Not in like production, but yeah, we've been like looking around it, and yeah, so our Harvester solution is going to be built on this probably sometime soon. Supporting HLS and stuff like that coming up with
and I have used an unreleased feature. It's watermarking.
Watermarking, yeah.
These people are cutting edge.
So this is going to be the situation. We're going to watch this stream. I'll get it set up. Give me 1 second, please. Oh, but before that, can you all like scan this QR code, assuming like it's scannable, and let me know that you get a web page with a video? Let me know if it is. If not, we'll have to fix it. Can I get thumbs up? Okay, Faisal Hussain's given me a thumbs up. That's the most important thumbs up I need. It's loading for you. Well, get a better internet. I'm just trying to grab the IP address, just check in. It looks okay. Yes, okay. So, right, I'll load this myself as well, just to see that we've got something. Okay, it's giving me a black screen, so that's not good. But the content doesn't really matter. We can look into the network and see what's happening here. So there you go. Look, it's me in the video, because I'm recording this camera in here, and you can clearly see the delay as well. Should have added another filter because you can see my bed, but yeah. That's as simple as it is. Like, that's all it's doing. As you can see clearly in here, it's making those TS requests. And this is just a protobuf conversion that like the browser will do to play it back into whatever, video HTML5 video player understands. But yeah, I'll turn this off. Did we all get to see that? Did we all like that? Can I get a thumbs up so that I can turn it off? Unless you want to. Okay. So all we actually did, I'll turn all of this off for now. We have a source. We transferred that source through Media Connect. We transferred it back into Media Live, which encoded it. So like, it's usable by browsers. It's HLS formatted. And then we gave it to a packager because we all have different devices, and the packager was packaging it for us. Well, instead of CDN, I actually did not use any CDN at all. I just used whatever media package had. And we have a usable video. And all we did was basically replicate how FFmpeg would have done it and just did it in the cloud. And it's infinitely scalable. It's not cheap, not gonna lie, but if you try to do it yourself, there's a lot of development overhead, engineering overhead, operational overhead that would have probably cost the same. So yeah, and I think I should also walk you through how I've set up Media Live output. So I'll just do like a channel, edit channel, and then these are the two outputs that I have. And just like FFmpeg, in here, the core settings that I had to do was like, 1280 by 720. That's the size that I was telling it. And this one is 640 by 480. So on a production world, I'd also have like other settings, like I'd have a 1080p one, I'd have a really terrible one, like a 120 pixel or something, like we're not going to go into any of the details. This is like very specific video engineering stuff, but this is a very typical setup that you could use to make it work. But yeah, I don't need any of this for now. And then yeah, a bit of noise stream for those. Oh, it's not. I just thought like I'd show you how like YouTube is also doing something similar. But yeah, that was it really. Any questions? Did we find it useful, completely pointless and useless? All of which are absolutely acceptable answers, by the way.